7.6, solving inequalities using addition or subtraction. Alright, to start this section off, I'm going to start with a study tip. So, you can solve inequalities the same way you solve equations by using the inverse operation to get the variable by itself. So let me just show you what I mean. So if I had x minus 4 equals 5, or I had x minus 4 is greater than 5, it's really the same exact way I do the work. So I would try to get x by itself over here by adding the 4, because it's the inverse operation, I get 0, and I would add the 4 on this side of the equation. And 5 plus 4 is 9. So in other words, x would equal 9 in this situation. So looking over here, if I had x minus 4 is greater than 5, this is an inequality, I would add my 4, get 0 out of it, but I would also add my 4 on this side of the inequality. 5 plus 4 is 9. I'm left with my x over here, and my inequality would stay greater than. So that's the only difference is this one is an equation on the left, and then this one on the right is an inequality. This is what this section is about, and I'm going to show you an example 1. So solving an inequality using addition. The directions would be just like this. Solve x minus 3 is greater than 1. Graph the solution. So the difference between an inequality and an equation in this type of lesson is we didn't have to graph the solution with an equation because you just would have been putting that number on a number line. Didn't really make sense to graph it. There's multiple solutions in inequalities, so we want to kind of model what it looks like. So you're going to do two different things. You're going to, one, solve it, then you're going to graph it. And this is how. If I have x minus 3 is greater than 1, I'm going to use the addition property of inequality. We learned about the addition property of equality. So the difference is this is of inequality. By adding my 3 to this side of my inequality. And then I'm going to add it also to this side of the inequality. So remember how I did my arrows? It's whatever I do to this side, I do to that side. And that's kind of where the inequality splits, is at the inequality sign. So my minus 3 plus my 3, I'm going to just erase this just because I don't want it to mess you up. My minus 3 plus 3 gets rid of that, and it gives me x all by itself. I keep my same inequality sign, and then I solve 1 plus 3 is 4. So what I'm saying is that x is greater than 4. Now I need to graph the solution and prove that. So you start with a number line. On the number line, you're going to put one right down the middle, excuse me, and that would be what we use to put 4 on. Now I'm also going to put a few spots on my number line that go to the right and that go to the left. So I'm just going to do 3. So 1, 2, and 3. 1, 2, 3. Make sure you label these correctly. I told you in class you have to know how to put numbers on a number line. So I'm going to start to the left. The number to the left of 4 would be 3, 2, and then 1. There wouldn't be negatives because it would be negative after my 0. I don't even have 0 on here. Then I'm going to go to the right, and it's going to go positive 5, 6, and 7. Because I started with the 4, that's where my circle goes. I have to decide, is it open or is it closed? If you remember, if my sign looks like this, it's open. If my sign looks like this with a line over it, it's closed. Don't forget that. That's kind of a key piece of information in order to get your number or get your inequality on a number line. Okay, so I'm going to keep it open. Now I have to do a couple test rounds. So let's use a number from this side over here. So we'll pick 2. Just picking 2. You could do 1, you could do 2, you could do 3. We're going to do 2. So what I'm going to do is I'm going to put in my 2. 2 is greater than 4. Is that true? Well, no, 2 is not bigger than 4. I'd rather have $4 than $2, so my $4 is greater. So that right there tells me I don't go to the left. But let me just check it to make sure. So I'm going to use 6 just to practice. So 6 is greater than 4. Is that true? Yes, 6 is greater than 4, so that is true. So that means I find my 6 on my number line, and I realize my number line is going to go in this direction. So this is the way I'm going to make it thicker, and I'm going to color it in. And that's how you graph on a number line. There's a couple things that can be tricky. Number one, if you don't graph it correctly and put the ordered, your numbers ordered, that will trick you up if you don't check it. They do get harder than this, so. Alright, so that's example 1. Example 2 is solving an inequality using subtraction. The directions would say something like this. Solve 15 is greater than or equal to 6 plus x. And then it says graph the solution. So let's start with rewriting out what we have. We have 15 is greater than or equal to 6 plus x. So now we're going to use the subtraction property of inequality, which is just like the subtraction property of equality. And this time, we have to recognize that we want to get x all by itself. In order to do that, I got to get rid of my 6. Because I recognize that my operation's addition, I'm going to use subtraction. And I'm going to take away my 6, because 6 minus 6 is 0. Whatever I do over here, I have to do over here. So I also subtract 6 on that side. That gives me x all by itself over here. I'm going to use and bring down my same inequality sign, and then I'm going to subtract 15 minus 6, which happens to be 9. So now what my statement is showing is that 9, my inequality, that says 9 is greater than or equal to x. Now I need to put it on a number line. So all I did was I graphed a few numbers. I started at 9 because that's the one I'm talking about. I have to determine, is it open or is it a closed circle? Well, that's when you look over at your inequality sign, you realize it's got the line underneath, so that makes it a closed circle, so you fill that in. And really make sure you filled it in properly, because if it looks like it's not colored in very much and I can't tell, I might mark you wrong. Now you fill in a couple practices. Well, if I've got 9 is greater than or less than, I'm going to take a guess for what x could be. So I'm going to go to the left of my number line. I'm just going to pick 6. Because 6 is right here, so I'm just going to fill it in right here. Is 9 greater than or equal to 6? Does that make sense? Is it bigger than 6? Yes, so that works. Now I'm going to try, is 9 greater than or equal to, and I'm going to go to the right of my 9 on my number line. I'm going to choose 12. Is 9 greater than or equal to 12? No, it's not. So no, that wouldn't work. This one, yes, it would. So now I find my 6 on my number line and recognize that I'm going to go this way with my arrow that I filled in. Remember, you're making it thicker than the line so you can recognize it. So if you're not using colors, you need to make sure I can see that that's where you're pointing to. So just looking back at our last inequality that we were just doing, the answer was 9 is greater than or equal to x. You can also word this inequality the same way by saying x, but you have to flip-flop your sign, is less than or equal to 9. And you're going to see this as a solution that you can do this. So this could be an answer or this could be an answer. It's just like saying x equals 9 or 9 equals x. There's no difference. It's still the same. The difference here is you're changing your sign. So I started off with having my sign facing my 9 and reading 9 is greater than or equal to x, to reading x is less than or equal to 9. And if you were to plug in those numbers from the number line, it would still make sense. So if I had over here, if I said 9 is greater than or equal to x, and x being 6, wouldn't it make sense that 9 is greater than or equal to 6? Yeah. Wouldn't it make sense that 6 is less than or equal to 9? Yeah, it would. So you can say them both ways. You can flip-flop them just like you could when we had, our equal sign. All right, here are some try-its for you. You need to solve what you're given and then also graph. So solve and graph, just like I showed you in the examples. The first two are from example 1, numbers 1 and 2, and the second two are from example 2. The answers will be on the next page. Make sure you also put the graph. And here are the answers for the try-it. Make sure that you recognize which ones are colored in with the closed circle and which ones are not, and which way the arrows go.